Hello, it says we are live, so I am assuming that we are live. Hi, everyone. I'm not sure who is around. This is always a sort of weird part of these sorts of things. Uh, it's a little one-sided, and by the time that I speak, it's 50 seconds, and then you write back. So first of all, welcome everyone who's around. I see there are 4 people in the chat, I guess including me. If you're looking for the chat, what's the best way to do this? I sent an email to everyone who is interested who had registered for the webinar, telling you what the chat is. I think I can put it in the chat room here and write. Hopefully you will see that. No. So anyway, if you want to go to the chat to participate and ask me questions, which I would love, obviously, we are at tlk.io. That's tlk.io/Reuven. And I'm probably going to share my screen in a few moments so that you can see that. And why don't we do that already? Why don't we screen share? And I'm going to share that desktop. And I've learned from previous webinars that people like to still see my face. Here we go. Good. Your screen sharing. Good. So now everyone should be hopefully seeing my screen share. Let me know in the chat if it's not the case. Yeah, it says present everyone. It's good. Stop. Present everyone. Okay, I'm going to assume it's working. Anyway, where you want to go for the chat is, let's see. Let's just do test.py. So chat room is in tlk.io/Reuven. You guys seeing me okay? Let's just make sure that people are actually seeing me. So before I begin, to make sure that I'm not just talking to myself. Am I talking to myself? By the way, I apologize if there's noise in the background, but basically my neighbor's practicing piano. So you can have the delightful sounds. Okay, thank you, Mike. Thank you for telling me. Okay, so I'm going to get started. I'm going to assume that there are people watching. At the very least, I see 3 people watching, and we'll go from there. So basically, my plan is to talk for about 30, 40 minutes. Lots of live demos and interaction. If you have questions, please ask them. And then we'll have another, say, 10, 15 minutes of questions after that, and then we'll go on from there. And I have a hard stop in another hour and a half just because I have a meeting with the Linux journal editors about something I'm writing. But basically, other than that, I'm happy to just keep chatting with you guys. Okay, so let's talk about objects in Python. I've got some slides, but I think I'm going to ignore the slides to a large degree just so I can sort of talk and give some live demos here. So look, let's start off with some basics here, right? Which is Python is an object-oriented language. And that is one of those claims that people talk about all the time, right? Like nowadays, almost every language, except for the purely functional languages, people love to talk about how their language, every language is object-oriented. But they fail to sort of say, what does that mean, right? Like, what does it mean for your language to be object-oriented? And what does it mean for everything to be an object, which is one of these terms that we hear all the time in Python. So I'm going to bring over, I start up an IPython notebook. Let's just drag that over here so you can see it on my screen, hopefully. Okay. By the way, I've been using IPython for quite a while. I've started recently using IPython notebook also when I teach. Oh, but now I've covered my face, right? All right, there we go. And I must say it has changed things dramatically for the better, not only because I feel like I have a better visual aid for showing people things, but then I can send them the IPython notebook file when I'm done teaching, and they have all the inputs and the outputs available to them that I went through. So if any of you are interested in getting a copy of this IPython notebook, I'm happy to send it to you after the webinar. Just send me email or catch me on Twitter, and I'm happy to do that. Okay, so oops, let's resize the window here so I don't cut myself off. Okay. All right, so we say that everything's an object. What does that mean? Well, it means basically 2 things. It means that everything has a type, and it means that everything has attributes. And once you understand these 2 things, you really sort of get the object system in Python. So let's start off with that first one. What does it mean for everything to have a type? Well, you might remember, or you might know, that in Python, if I say x equals 5, right? So I've now assigned 5 to the variable x. And I can say then type of x, right? And type of x will then return int in this case. It will tell me that x is an integer. Well, that's like a no-brainer, right? Except that's not entirely true, because x is not an integer. X is a variable, and a variable in a dynamic language doesn't have an inherent type. That's the big difference between dynamic languages and statically static languages, right? Statically typed languages, where in a dynamic language, the variables don't have type. Rather, the data has type. And so X doesn't have a type. X is pointing to something with a type, 5 in this case, and it's an integer. Okay, so we can say then that, oh, someone's getting a video format. Okay, all right. Sorry for responding to all these things. I'm just always curious to know, making sure that everything's working. So I can do this with any object in Python. I can ask it what is its type. And this is true for simple things like type of ABC, right? It's going to give me a string back. Type of a list, 1, 2, 3. It's going to give me a list back. Very nice. But I can do that for more complicated things too, right? I can say import OS. And the type of OS is, of course, a module. And I can say def foo pass. It's a simple function, right? I can say type of foo is a function. So lots and lots of things are objects. By the way, one little funny, interesting thing that I've always found is that int and stir and list are all built-ins, right? They're names defined in the built-in module, so they're available to us. So I can say, list of ABC, right? And that works just fine. But I cannot say module. If I say module, Python will give me a name error saying that the name is not defined. Why are some names defined and some are not defined? I don't know. Interesting question. In any event, they didn't ask me before they made that decision, I guess. In any event, so we see now that all these different things have types. But we can go even further than that. We can say that what's the type of int, right? Like we know that the type of 5 is int, but what's the type of int? And we find out that the type of int is type, meaning that classes are also types in Python. Basically, to say that in Python everything's an object means not only are the objects that we normally think of being objects, but also the classes are objects. Okay, and we'll get back to what is a class and what does it do in a little bit. But okay, if those are the that points that everything is a type, has a type. I'm sorry. And by the way, in Python, the words type and class are basically the same. So when we say type, we mean class. When we say class, we mean type. Okay, that's all well and good. So I also mentioned that everything is attributes, and that's where the real core of the object system comes in. So you might know that attributes are these things that come after the dot, right? So if I say import OS and I say os.pathsep, right? So pathsep is not a variable. Pathsep is an attribute of OS. And so when I use the dot, I mean, I'm telling Python, go into the OS object and grab the attribute, which we can think of sort of kind of as a private variable. You can think of it as its own private object dictionary, but it's not in the object, right? It's sort of part of the object. So we're saying go into the OS module. Oh, here, Nasser asks, this is only about Python 2. I'm using Python 2, but I will try to point to all the places where Python 3 is different, and there will be a few examples almost certainly about Python 3. But everything I'm saying I think is relevant to both of them. Good question. Anyway, so the dot means that I'm going into the pathsep attribute of OS. Well, here's the thing. I can change any attribute I want on any object. So I can say os.pathsep equals ABC, right? And now I've changed it because there's really no private or protected in Python, and so I can change any attribute that I want on any object. Okay, so if I now, well, here's the thing. I can go to OS, and if I know that pathsep is an attribute, I can set it. Actually, I can set it no matter what, and that just becomes created. I can grab the value of pathsep from OS. Oh, goodness, it says live broadcast will begin soon. Have I not started the live broadcast? No, it says that. Says that everyone's doing. No, well, I'll just do. Oh, I'm told the prod. Okay, sorry. Anyway, so here's the thing. If I want to know what attributes are available on OS, I can say dir of OS, and dir of OS returns this really long list of strings. Well, that's well and good, but now I'm sort of stuck, right? Because look at this. I've got a list of strings, and here I've got just plain old names, the attribute names after the module name. So somehow there's got to be a way to move between these two worlds. There's got to be a way to say, if I've got a string, I want to turn it into the dot syntax, and if I've got the dot syntax, I want to turn it into a string. Well, we can certainly do the second of those, or the first of those, I guess. So if I want to do os.pathsep, right, I can also say, I can use the built-in getAttr function. And getAttr takes 2 parameters, 2 arguments, os, which is the name of the attribute, and then a string, pathsep. So basically, there's no difference between saying os.pathsep and getAttr os.pathsep, where the second one here is a string and the second one here is a name after the dot. Okay, well, who cares, right? Like, this is kind of interesting, I guess, in terms of learning how the language is working. But why does that matter? Well, it matters because attributes are the key thing to understand how Python objects work. And we're going to see that more and more as I discuss things more and more. By the way, there's a similar function called setAtter. If I say setAtter, OS, pathSep, and it takes a third argument, say 1, 2, 3. Might not like that because it's not a string. And now if I say OS pathSep, right, it's going to have 1, 2, 3. I guess it likes it just fine. You know, it's not going to complain too much. So you can see that we can set and get attributes using these built-in functions, or we can use the dot syntax, which most people will use because it's just easier and more straightforward. And in our day-to-day lives, that's fine. But let's say I'm writing a shell, let's say I'm writing an interactive program that wants to retrieve the attribute from something, right? So I can say, you know, attribute name equals raw input, give me an attribute name. And by the way, this will be different in Python 3. Right, because in Python 3 we use the input function rather than raw input. And if I do that, then I can say, you know, print OS, or I should say print getAtter of OS attribute name. Right, and so if I run this, it's going to ask me if I'll say pathSep, why not? And it gives me 1, 2, 3 back. So I can use getAtter and setAtter for dynamic setting and getting of attributes, which I obviously can't do if I just have strings. I can't say OS, right, pathSep, right? That just will not fly in terms of Python syntax. Okay, so we've got these attributes. We can set them on all sorts of objects. So every object has a type, and every object has attributes. And when I say every object, I mean it. So I can say dir on 5, and I'll get lots of attributes back. I can say dir on ABC, and I'll get lots of attributes back. I can say, remember my foo function, right? Here's my foo function. Type, okay, so type of foo is a function. Well, I can say dir on foo, and sure enough, we see attributes there. By the way, this is where Python stores the default values for functions. So for function attributes. So if I have a function that takes 3 parameters, and the second 2 get defaults, those will be stored in a tuple here in func defaults. And all sorts of other things about functions are stored in their attributes also. So really, attributes are key here, and obviously the types are key. Okay, well, why is that important? How does that have to do with object-oriented programming in Python? Because that's where object-oriented programming is at. Object-oriented programming in Python basically means we are creating a new namespace, and that namespace will have its own attributes. And then we will use those attributes as basically the equivalent in other languages of instance variables, class variables, and methods. All right, so what do I mean by that? Let's start with something really simple. Right? So if I say class foo, let's just say, class foo. Here in Python 2, we have to say that we inherit from object. Python 3, you don't have to say that, but the effect is the same. All right, and here I'm going to say, well, pass. So my class really doesn't do very much. Right? So now, if I say, what's the type of foo? We'll see that the type is type. Well, that's really interesting, right? Because the type of stir was type, the type of list was type. So basically what we've done is we have created a class. We have created a new data type that is at the same level, right? Has the same authority as the data types that are built into Python, right? They're all types. So when we're creating a new class in Python, we are gaining a great degree of power. By the way, this is new. This is why you have to, relatively speaking, in the last 10, 15 years, that's why you have to inherit from object in Python 2. If you don't do that, you get what's called an old style class, and then this all falls apart. So you really, really want to inherit from object or from something that inherits from object. Okay, so now I've created my new class, right? And my class has attributes on it as well. Well, let's create a new instance of that class. So f equals foo. Right, so I've created my new instance. If I say, what's the type of f? Well, it's going to say it's an instance of foo. Well, we sort of knew that already. If that were not the case, we'd really be in trouble. Okay, well, how can I set an attribute on f? Well, just like I set an attribute on anything else. f.x equals 100 and f.y equals 1, 2, 3. Right? And now I've created these two attributes. And if I say dir on f, I'm going to see a whole bunch of attributes, and we'll talk about those in a moment, plus x and y. So we can see that I've added 2 attributes to my instance. Well, that's not a surprise, because we already said, and we already saw, that I can take any object in Python, just about, and add attributes to it, modify attributes that are already defined, and retrieve the attributes from it. So I'm not doing anything really exciting here. Except if you think about it, in most other languages, maybe except for dynamic languages, right, but certainly in static languages, you can't just sort of randomly add new fields, new instance variables to objects on the fly, right? We had a perfectly valid instance of f here. And then we took that instance of f and we added x and y to it. And this means that if I say G equals foo, right, so G is now also an instance of foo. And if I say G.x, it's going to give me an attribute error. It's going to say, I don't know about that attribute. So something weird is going on here where I can add an attribute to an object and the class doesn't really know about it. Well, this is not necessarily a good state of affairs. This is not really what we want to be doing. What we want to be doing is having our objects, when we create them, be relatively similar, right? The whole point of using a class is that we get a new object and the object has a whole bunch of attributes already set on it. So in a lot of languages, you have what's known as a constructor, right? And the constructor creates the object. And in many other languages, you have a distinction between the constructor, the actual function, the actual method that creates the new object, and the initializer, meaning the method or the function that modifies the object after it's been created. And this second technique is what we use in Python. This is inherited from the world of Smalltalk, right? So what happens is, in Python, I can, if I want to, work the way that I just did. I can take an object, create a new object with a basically blank class, add new attributes to it, and work with it. But no one wants to work that way. What I want to do is create my new object, and I want to have that object get attributes by default. And I'm going to do that by defining a method on my class. I'm going to say here class foo. I'm going to overwrite the existing definition of foo. I'm going to say class foo def init self. I'm going to say here, oh yeah, sure, self x equals 100, self y equals 1, 2, 3. All right, and so now I define my class this way, and I'm going to say f equals foo. And now I know that f.x is going to be 100 and f.y is going to be 1, 2, 3. Well, here's the thing. It's important to understand what's going on here within it, and there are a few issues. First of all, what's the self thing, right? And everyone who starts doing object-oriented programming in Python very quickly learns that self, first of all, not a reserved word, but a word that everyone uses, right? You do not want to be the guy they make fun of for not using self. You certainly would not want to use something as horrible and ugly as the word this, right? No one does that, at least I hope not. So self is just a very, very strong convention in the Python programming world saying, this is the object itself. Well, what do you mean this is the object itself? What do you mean self is the object itself? Well, it turns out that init is invoked after the object has already been created. So by the time init runs, we have our new foo object, and it knows that it's a foo object. If we were to ask it, what is your type? It would say, I'm a foo. But the thing is, init gives us a chance to sort of dress our new object, to add to our new object new attributes. And that's exactly what we do. Self.x equals 100 and self.y equals 1, 2, 3. So now if I say f of x and f of y, we see that I get these two attributes. And that works just great. So really init is like our chance just before the object is returned to the user to add those attributes. And of course, we can add however many attributes we want. They can have whatever names they want. Yeah, whatever attributes they want, and they can point to whatever kinds of objects they want. Indeed, because everything in Python is an object. So 100 is an object, right? 1, 2, 3 is an object. We can point to more complex objects if we want. Well, let's make something a little more interesting, right? Let's say class foo object. Let's say def init. Oops, def init self x and y. Self x equals x, self y equals y. All right, and now if I say f equals foo, and let's say 100 and 200, or let's say ABC. Right now, f of x is 100, f of y is ABC. Well, let's think about this a little more. All right, so I got a function here. My function is init. And the function init gets 3 parameters. Self, we know, is passed automatically by Python. It's the new object. But then we're passing these other 2 parameters, x and y. And what's happening is the foo class takes whatever parameters we've passed to the object, to the class when we executed it more or less, and it hands those off to init. And so we get an x and y. That's great. What people fail to understand a lot of times, though, is that there is no connection whatsoever between this x and y and this x and y. The x and y on the right are local variables inside of our function. They're just like any other local variables inside of any other Python function. Self, x, and y, only 3 of them. On the left-hand side, though, we have x and y, the attributes on self. Now, to us semantically, obviously, we understand that we're trying to do the assignment here from x to self.x and from y to self.y. But you have to remember that the x on the left is not at all the same as the x on the right. 2 totally different types of creatures here. The left attribute on the right variable. So we can do this all the time, of course. We can create new objects, and that's pretty easy and straightforward. Now, the thing is, Let me just go back to my notes for a moment to make sure I'm not forgetting something absolutely like critical. Yeah. So let's say, now a lot of people who come from other languages say, well, that's kind of weird, right? I'm just going to go directly to the attributes themselves. I'm going to read them. I'm going to write them. I know what I'm going to do. I'm going to create methods that are called getters and setters, right? So class foo object. I'm going to say def init y. Let's not make it pretty. Self y equals y. And then I'm going to say something like, def get x self return self.x. I'm just going to do this for x so I don't bore you all to tears. Set x self new x. And I'm going to say self.x equals the new x. Right? And so now I could say f equals foo of 100 and abc. And I could say f dot get x, print f get x. I could say f dot set x of, let's say, 200, and let's print it out again. And sure enough, if I do all these things, we're going to see that first f of x is 100 and then f of x is 200. But no one does this. Please don't do this in Python. And the reason is that in Python, we like the idea of going directly to our attributes. We don't like the idea of enveloping things inside of getters and setters. We can do it. I mean, as I like to say in a lot of my classes, the problem with this is that it works. And the reason I say that is it will work just fine in terms of technically speaking, but aesthetically speaking, it's not very Pythonic. And we like the idea of going directly to our attributes. Now, when they hear me say this, a lot of people say, wait a minute. There are a few problems with this. Number one, isn't the whole point of object-oriented programming to sort of restrict our access and to make us go through methods? And I would say, actually, there's something to that. Right, that traditionally, say in Smalltalk or Ruby, which is shall we say, uses the Smalltalk object model, we are really using methods to mask and to stop people from going directly to the attributes. Python, for whatever reason, decided long ago, no, we want to do it this way. A second aspect, so maybe it's a gross violation of the contract that object-oriented programmers have with their languages, but Python's been doing it this way for a long time, and it's not going to change. A second, I think, more valid question that people ask is, well, wait a second, what if I want to restrict access or do something that's programmatic? Are you telling me I really can't do that with attributes? And the answer is sort of. So here's the thing. When would you want to do it programmatically? Well, you can write a method, right? We can write methods all the time. But sometimes we'll start off with a simple attribute, and then we'll want to move on to something that's programmatic. So let's say my getX, right? So I want someone to be able to say f.x, all right? And that'll work just fine, f.x. But I want to make it so that if I say f.x, let's make it like a safe in a bank. So if it's before 8 a.m., if it's after 4 p.m., it won't let me get that value. Clearly, the attribute itself is not going to be shielded in that way. But Python will let me get around that. Python will let me put on what's called a property. If you want, we can talk about this a little bit, but properties basically allow us to create methods that look like attribute calls. So when someone gets or when someone sets an attribute, they'll actually be invoking the method. And that way we can keep our API very attribute-ish, but we can do programmatic stuff behind the scenes. Okay, so we've got our little, we've got our little class here. Let's go back to a class, but let's actually do something fun in the class. Let's say class foo object. Here's a fun one. For I in range 5, print I. And then let's say here, def init self x and y, self x equals x, self y equals y. First of all, will this run, right? Like, people look at this and they say, oh my God, what the heck is going on? Well, first they're saying what the heck is going on, because really I should remember to use my parentheses. And this will not work in, oh, fine, let's make it work in Python 3 also. For the Python 3 folks out there, all 2 of you. No, I'm sure there are people using Python 3 nowadays. I just haven't actually met any. Well, that's not entirely true, but it's mostly true. In any event, so I can actually do this, right? I can have a for loop inside of my class, and it will run, it will do all those things. And now if I say f equals foo, right, everything's working just great. Now that's, oops, f equals, well, it works great if I enter the right number of parameters, 100 and ABC. Well, here's the thing, how can this possibly be? How can it be that I can run a for loop inside of a class? Well, it's really important to understand the distinction between defining a method, like I've done here with def, and defining a class, like I've done here with a class keyword. If I say def, what I'm doing is I am creating a function object. And by that I mean I'm creating a new object of type function. I'm assigning the name init, under, to point to that function. And I'm saying, and the body of that function, I don't want it to run yet. I'm going to wait. I'm going to sort of freeze the body of that object until I call it. And then when I finally call init, or the foo constructor calls it for me, then the body of the function actually runs. And that's fine. So anything inside of a def is not executed right away. By contrast, everything inside of a class is executed right away, as we can see from this for loop, which is kind of crazy, right? And why is that? That's because def has to execute. If we don't execute def, then the method doesn't get executed, doesn't get defined. If the method doesn't get defined, then it won't exist when we actually need to run it. So inside of a class statement, everything executes, but you can think of it as sort of like being a module. You can think of it that everything we define becomes an attribute inside of our class. So for instance, if I say class foo object, and I say def A, B, C, D, E, F, that doesn't really matter, pass. Watch this. Now if I say, right, dir of foo, we're going to see A, B, C, D, E, F is an attribute defined on the class foo, meaning any definition we make here, including methods, are defined as attributes on our class. Well, that's really kind of wild. Can I define variables too? Oh, absolutely. Class here, let's do one of my favorite examples. Right, so let's do class person from object. Right, and now I'm going to say def init, so first, self first and last. Right, self first equals first. Self last equals last. So far, so good. But let's add something here. Let's say population equals 0. Okay, so if I execute this, now I can say, hey, person population, how many people are there? And it'll say 0. If I say P1 equals person A and B, right? And now I say once again, hey, person population, how many are there? It'll still say 0. Well, that's because I haven't updated it, right? So let's update it. How can I update it? Well, in init. Init is going to execute every time I have a new instance of person. So what I'm going to do is I'm going to say person dot population plus equals 1. And now if I execute that, now if I say P1, well, if I say person, let's just execute these again, I guess. Now there's 0. And now I say create a person. And now I say, look, there's 1 person, right? Because we executed init again. And so init increased person population by 1. Let's think about again what this means. This means that inside of a class definition, I can define attributes on the class itself. Now, what would happen if I just said here population, right? Would that work? No, it definitely would not, because it's not an attribute. How do I know it's not an attribute? There's no dot before it. No dot, no attribute. It would have to be a local variable. Now, it's not going to give me a complaint. Python's not going to give me any trouble when I define init, but when I run init, it's going to say, hey, what's this name population? I can't find a name like that. Population, I can't add anything to it. So we need to say here, person.population. Is person defined? Is it available when we're running init? Oh, absolutely. Because when we're running init here, right, we're running it in the scope and we see global variables, and person is defined to be a global variable, meaning a variable at the level of the file in which we're running. Okay, so far so good. So here's the thing. People sometimes discover down the road that they can do something like this, p1.population. And what will be the value of that? Strangely enough, it's also 1. And this is another way in which attributes are different from variables. So you might know that in Python, our scoping rules are typically LEGB, right? Which means local, and enclosing function, global, and built-in, right? So built-in. So if I am inside of a function and I say print x, the function is going to look now first, for x inside the function as a local variable. Then it's going to look for x inside the function and the enclosing function if I did a define inside of a define. Then I'll look at the global level, then I'll look at build-ins, and I can't find any of these. Well, that's it. Then it's going to give up. But that's not what's going to happen with the attribute. Attributes are treated differently and specially. So what's going to happen is when I say person.population, when I say p1.population, first it's going to look for the population attribute on p1. Okay, that makes sense, right? And p1, as we know, is an object. That's of type person. Is it going to find the population attribute on p1? The answer is no. Why or why not? Because I defined the population attribute on person. So it shouldn't really find it, and yet it seemed to. Well, that's because if if Python doesn't find the attribute on the object itself, it then turns to the object's class. And so after looking for population on P1, it then looks on person for population. Yeah, it looks for population on person. If it finds it, which it does, it returns the value. So far, so good. If it does not, though, then it keeps going. It goes up to what person inherited from. And so we go up the entire inheritance chain. And so, in fact, what we have with the looking up of attributes, think of it. This is the way attributes look. They first look on the object, then they look on the object's class, then they look on the object's superclass. Well, when I'm invoking a method, where do I want to look? I want to look on the object. It's not going to be there. Then I look on the object's class. Then I look on the object's superclass. That is how inheritance works in Python, folks. It's because of these attribute rules, these attributes, I don't know, scoping rules or lookup rules, name resolution rules. So and it just, the moment I figured this out, the moment I read enough about it to understand it, the moment everything became clear for me in Python. There's no special rule for inheritance and special rule for methods and special rule for data. It's all one rule. But it's one rule that's a little weird and different to get used to. Okay, so let's try something else. Let's say I decide to be a smart aleck, right? And so now I'm going to redefine person again. But this time I'm not going to say person.population because I know that I don't need to say person population. I know that I can say self.population, right? And so now if I say, let's execute this, and now I'm going to say person.population, and the value is going to be 0, of course, right? Because I haven't done anything with it. And I say P1 equals person, A and B, right? And now I'm going to say, what's P1.population? And it's going to be 1. Looks pretty good. And I say person.population, and it's going to say, oh my God, not at all what I wanted, right? Well, what the heck is going on here? Well, what's happening is that I was foolish enough to say self.population plus equals 1. And what that means, basically, is self.population equals self.population plus 1. Well, now let's think about what that means. Always the right side of assignment happens before the left side of assignment. And so the right side of assignment here, we're saying self.population. Is there a population on self? No. On our new object, there definitely is not. How do we know? Because the object was just created, right? It doesn't have any attributes other than those we created. So self.population does not exist. That's fine. We go to its class. Does person.population exist? It absolutely does. Its value is 0. 0 plus 1 is 1. Now we go to the left side, and now we do our assignment. And our assignment is to self.population, and that's where we set it on the instance. And now we have an attribute called population on the instance and an attribute called population on the class. And they do not have the same value, and heaven help us. And this is something you obviously want to avoid at almost all costs. So I'll just take a drink of tea. Okay. So now the thing is, does this mean you never want to use self when you're writing an instance method? No, on the contrary, you often want to use self when you're writing an instance method. But you have to be really careful not to do assignments to it. You can invoke methods on it. So let's say, I have a list up there, right? Stuff equals 1, 2, 3. There's no problem at all if I say, self.stuff.append 4. That will work just fine because I'm not overwriting it. But if I were to say self.stuff equals self.stuff plus 1, 2, 3, well, now I'm going to be in trouble, right? Because I'm doing assignment. And once again, I'm going to set an attribute on my instance, which I didn't really mean to do. All right, well, let's talk a little bit about inheritance. And then I think in a few minutes, there'll be time to take some questions if you have. So let's take the most classic example, right? No pun intended, classic example of object-oriented programming that people use with inheritance. I'm going to say class, person, object. Let's just rewrite it. Def init, first and last, self first equals first, self last equals last. Okay, so far so good. Now actually, no, let's do this. Def full name. Oh, stream stopped. Is the stream working for others? It's working for me. Haha. Oh, it's just buffering. Okay. Okay. So now I see def full name, and let's do self. I'm going to say return. Let's do format self first, self last. So now if I say P1 equals person A and B, I can say print P1 full name. Let's think about also what's going on here. When I say P1.fullName, well, we look for full name on the instance. Does it exist? No, it does not. All right, so what happens then? We look on its class. Does full name exist on the class? It absolutely does. And here's where Python does its rewriting magic. Here's where Python says, oh, you said P1 full name. What you really meant to say is person.fullname of P1, right? And then it's going to return that, but it doesn't really matter that much. Okay, so we're going to print P1.fullname and we get the value back. So far, so good. Now let's create another class. Let's create an employee class. And I told you this was the most classic thing ever in objects, right? So now I say class employee. And we're going to say it inherits from person. And I can just say pass now. Pass means I don't do anything, right? Like many employees. Anyway, so now I can say E1 equals employee of, C and D. And now print E1 dot full name. And sure enough, right? So we print P1 of full name and E1 of full name. Everything's great. The only problem here is, of course, is that employee is doing nothing special or new. So what we really need to do is say def init self first last. And let's say that our employees have something special, right? So let's say ID number, because that's what all employees love to have. Self first equals first, self last equals last, self ID number equals ID number. And this will work, right? So now if I execute all this, this will work just fine. Oops, sorry, except for the fact I need to add a number there. Let's say they're the founder. So that works great. The only problem is now I've got this duplicated code, right? I'm setting it here and I'm setting it there when employee is inheriting from person. So what I do in this case is very simple. I'm just going to invoke person init self first and last. Now, why does this work? This work first. Once again, let's make sure this works. Once again, this is working because of attributes. This is working because when I create a new instance of employee, right? So the employee class creates a new instance of employee. Then it calls init and says, hey, init, here are some parameters. Please add these attributes to the object itself. Or here are some parameters. I want you to add whatever attributes you want. And inside of init, we add the attributes we want. Well, there's nothing stopping us from calling a different init. Actually, there's something stopping us. You can't use any instance of anything anywhere, right? The self needs to be an instance of either employee or person or something that inherits from person. But let's ignore that small issue for now, right? I can invoke person.init and I can pass it the object, and that method will now add those attributes onto the object. We're just adding attributes. And then that init comes back, right? It returns, and now we add whatever attribute we want, and then we go. So now if I say also, print E1 ID number, it can do that, right? It has ID number 1. And it all comes down to attributes. And so how does it work for when I say E1.fullname, right? It goes to E1, doesn't have it. Looks at employee, doesn't have it. Looks on person, it has it, and it executes it. And it passes self to that as that parameter. And I just love the elegance and the simplicity of this object model, that everything comes down to attributes and everything comes down to the sort of inheritance of attributes. Now you have to remember also, what was I going to say, that our classes are objects also, right? So that's why I was able before to put population on a class, because there's no difference between setting an attribute on a class and setting an attribute on an instance. But the big difference is, the main difference is, I guess, if there is one, that classes can inherit from one another and they can create new instances, whereas, of course, instances cannot. But a class is an instance. It's just an instance of type. One last thing that I just want to show you guys, and then we'll do some Q&A, assuming there are. Let's just go, yeah. So let's say I want to now print E1, right? So I get that. That's the, or even if I just do it here in IPython, right, I can get the printed representation of the object. Well, that's pretty ugly. What I really like to do is have the object represent itself more nicely. Well, that's okay. I can do that. I just define a new method, def repr, representation, right? And repr has to return a string. So here, let's return something like this. Return employee name, self ID number, and self, why is it self full name. And now, oh, I did actually try to put one. And we see here this happens. Now, this is one of my favorite parts of Python. All these methods override of operators. They're like 40, 50 huge know you can have two behaviors. One of the most common ones, either or scale. They have slightly different uses, but if you only define one, I suggest defining repr because that's defined further than there are cases when the repr won't work. So here you see I do print E1. E1 is turned into a string, and it's turned into this string, and we see employee number, whatever, full name CD, and we have it. And obviously, oh, excuse me, it's been a long day, folks. I've been up for a long time, and there's more to go. So the thing is, when I I could define repr also on person, but that's not going to know about the special employee stuff. And there are just a ton of those methods you can define here. One more example, just because I love this one so much. Def get item self index. If you've ever wanted to have square brackets work on your object, right? It sounds like a late night commercial. Have you or someone you know wanted to use square brackets on an object? Well, now is your chance. So get item is the method that's actually invoked when we use square brackets. So if I say now, here, return, let's do the same, self, full name, index. Right, so now if I say print, oops, let's do here, print E1, 2. Yeah, that'll do it. So I get D. Now why D? Because the full name is, of course, CD. And so I'm applying square brackets. The square brackets are sent to here, and then we get the index. So now the thing is, index, because of the dynamic language, index could be a number, it could be a string, it could be all sorts of things. You can decide to give different values back in different ways. So for instance, the shelf module in Python that comes with Python that allows you to store things to a Berkeley DB file, it uses square brackets. But when you're using the square brackets, it's not actually going to a dictionary or to a it's not going to a dictionary. It's not going to a list. It's actually going to disk. But it uses the API of the square brackets to let you use that. I think that's the basic stuff that I wanted to get across. Like for me, the moment that I understood that the attributes are at the core of all this, suddenly everything started to make sense. I started to understand why it's important to understand attributes, why it's important to set them, why we can set them, how inheritance works. And also, by the way, some of the more sort of subtle, magical, interesting parts of the Python object system have to do then with how we treat attributes. So, if you try to retrieve an attribute that doesn't exist, so there's like there's a get attr, there's a get attribute, there are all sorts of methods you can define on your class that then affect your object, obviously, which provide us with some element of private, some element of protected. Not really, but we can at least pretend and feel good about it. So if there are questions, I'd be delighted to answer them. If not, I'll get some sleep. That's a joke. I don't really get some sleep. I got a phone call with Linux Journal later. So any questions, folks? I know it takes a little while in between me talking for you guys to actually, I'll put them in the chat also. Another drink of tea, meanwhile. Silence. Silence, no questions at all. Everyone's even more tired than I am. All right. Well, if there are no questions at all, I guess I will end on two or I'll give you a few more chances for questions, but meanwhile, I'll make a few advertisements, shameless self-promotion, as people like to say. Number one, I see a few names of people I recognize who have bought my book. I really, really appreciate it. Oh, here we go, Design Friends. Great. I'll get that moment after the commercial break. I really appreciate those of you who have bought the book and who come to the Hangout, come to the webinar. I'm going to do these more often. I really enjoy doing them, and I'm going to try to do them like once every month, once every 2 months. If you've not bought my book, I will be happy to provide you with a coupon code for coming to the webinar to give you a nice discount on getting it. I'm also going to be starting, it looks like, I think in another month, maybe May 1st, maybe June 1st, I've got to figure it out, a new product, which is going to be a monthly subscription to Python exercises. So the idea is that you'll sign up. I'm going to get some of the details in place, but the idea is for a monthly fee, every Monday you'll get a new Python sort of exercise that you'll work on, and 2 or 3 days later you'll get email automatically with the solution. And my plan there is to have special private webinars just for the people who are participating in that subscription product to go over the exercise and discuss them wherever you happen to be. And some people will be earlier and some people will be later. And we'll also have a forum where people can share answers and ideas having to do with them. But definitely, like, part of my PhD research had to do with I was in a research group where we really believe strongly that people have to people have to work, sort of make mistakes and work on things in order to basically, if you don't make mistakes, you're not going to learn. And so going through exercises and making those mistakes is inherent in that. Oh, okay, design patterns. Nasser, so you have, by the way, I'd be curious to hear where everyone's from. So Nasser, you say, what's your take on design patterns in Python? Are some of the traditional gang of four design patterns not needed in Python? So let's first let's first define our terms a little bit. So design patterns, for those of you who don't know, the idea is to provide a common language for how we describe sort of object design. So it doesn't really mean this is my class, right? Instead, it means this is the way that a number of different classes will interact. I guess it could be just one class. I guess it could be. So I think for a long time, I was pretty convinced that design patterns were this relic from static compiled languages, and that they were not really necessary in Python or other dynamic languages. And I'm beginning to think that was kind of wrong. It could be that we can implement these design patterns with a really short amount of code. But the point of the design patterns is to get you thinking about the relationships among them and what happens when you do different things. So for instance, decorators in Python are incredibly powerful. And I've heard many people say, and I think rightly so, that they actually allow you to do much more than just the decorator design pattern. But that being said, the idea of a decorator is an important one to understand, whether you're in Python or in another language. And once you get that idea, then you sort of can't get it out of your head. So look, I've got the Gang of Four book on my shelf. I've even tried to read it several times, not very successfully. Maybe that's me. Maybe it's not written well. Maybe I'm just too tired. I don't know. So I'm not sure if reading their book is necessarily the way to go. But there are a number of resources I've found online here and there that talk about design patterns. And some of them are really important to understand. Everyone loves to talk about singletons, right? Singleton. If you talk about design patterns, everyone mentions that. But there are others that are also important. So for instance, a factory pattern, right? The idea that I should be able to create a bunch of different kinds of objects. Well, in Python, we can do that with a dictionary, more or less, right? So the implementation is trivial, but the idea is hard. And I was actually at a company a number of years ago. This was a Ruby project rather than a Python one, but the same idea applies, where the guy had come from Java, and he was a super nice guy, super bright guy. He could not get through his head that he should not be, he doesn't have to create oodles of classes and if-then statements or switch case statements, as it was in Ruby. All he has to do is create a dictionary and pull the right thing out of the dictionary for his factory. And he was having a really tough time understanding this. And I think if he had understood these design patterns better, he would have seen how the implementation is trivial even when the idea is deep. Anyway, so I hope that answers the question. So until I get more questions, I'll add. So if you want discount codes, I'll give them to you. I'm also going to send out email letting people sign up for this new, or for announcements having to do with this new monthly exercise project. And the other exciting news is I have decided to devote myself full-time to, or almost full-time, to training, both giving in-person classes and online classes and books and projects and so forth. So any and all feedback that people can give me on what's interesting, not interesting, what problems are you having that might be useful, I'm going to be putting out some sort of like short Python cheat sheet probably the next week or two, as part of just an array of different things I'm going to be offering, some of them free, some of them not. And I'm hoping to get my name out and get lots of people enjoying working with these languages and technologies that I like working with. Give you last chance or two, folks in the chat. I think that we've reached the end then. Well, I really appreciate people coming by and participating. I appreciate the questions. I hope I didn't yawn too much for your sakes. If you're interested in getting, I'm going to save this IPython notebook. So if you're interested in getting a copy of it, I'm happy to send it to whoever you want. You can just contact me. I guess I'll write it here because it's not obvious, right? You can just email me at Reuven@Lerner, or you can get me on Twitter at ReuvenMLerner. And either way is totally fine with me. Oh, Nasser, I love you. Yes. Well, I mean, yeah, anyway. You got my book. Excellent. So great. Thanks everyone for participating, and I will send out a notice about where you can get the video recording and other stuff, and what else, and the next webinar, hopefully in another month or so. Thanks everyone for participating, and I hope to see you again soon. All right, I'm going to turn this off now. Stop broadcast. Bye-bye.